All right, boys and girls, welcome back to the drive-through for my third attempt at this lecture. That's a 3 mix for those of you keeping score at home. Another shout out to all the high school kids that have jobs, learning about the future, learning about life, learning about what jobs they may not want to do when they're older. Those are all great things, and they're hardworking, and they don't get any credit for that. So, all right, conditional probability. That would be when the probability of something or the likelihood of something changes based on other information that is known. For example, what is the likelihood that you will spend more than a year in jail in your life? It's like 0.0001%. 1 out of 10,000 people spend a year in jail. What's the likelihood that you will spend a year in jail if you were born in one of the 10 poorest zip codes in the country? It's like 15%. So 15 out of 100 people from the poorest zip codes spend a year in jail. And so, obviously, that doesn't seem fair, and people do things about that. They try, at least. And it starts with just gathering the data. So, the dependent probability, the conditional probability, is based on a certain event happening. So, in this chapter, or this section, you will often say, what is the probability of event B happening, given that event A already happened? In my previous example, it's what's the probability that you will spend a year in jail, given that you are from the poorest county. So, this is how you write this. What is the probability that B will happen, given A has already happened? That's what we're doing in this. Okay? And the equation for this, the probability that B will happen, given A already happened, is the probability that B and A will happen over the probability that A happened. Okay? So, this is a typical chart for this section, and we're going to pause the video and once again real quickly fill in this information so we can kind of show you how that actually looks in a real situation. Okay, so we gathered some information about the people sitting in this room, and it turns out that there are 5 males in this room with a job, 6 males in this room without a job. There are 6 females in this room with a job, 4 females without a job. Okay? My first suggestion is when you get these little charts, you should do your totals and label them. So that means there are 11 males in the room total, and there are 10 females in the room total. Sorry. There are 10 people with no job in the room, and 11 people with a job. And there are 21 total people in the room. Okay, that's now the completed chart. So, what if they asked, what is the probability of having a job given that you are a female? So this is conditional probability. We have already determined that you are a female. What's the probability that you have a job? Now, I don't want you to use an equation to do this. You would not do that. Okay? You would look and say, okay, what is the probability that you have a job over in this column, given that you are a female? Well, how many of those people have jobs? 6. And how many people are there? How many females are there? 10. So that's 60%. So if you are a female in this room, what's the probability that you have a job? 60%. Now I'd like to show you how this relates to this equation right here. So take a good look at that equation. The probability of B given A is the probability of B and A divided by the probability of A. So, the probability of having a job given that you are a female is equal to the probability of having a job and being a female divided by the probability of being a female. Okay? Well, what's the likelihood that you have a job and are a female? Well, there are 6 females that have a job out of 21 total people. Now we're taking that out of, so the likelihood that you have a job and are a female are 6 out of 21. What are the other outcomes that could happen? Well, you could have a job and not be a female. That wouldn't work. You could have a job but be a male. That wouldn't work. And you could not have a job and be a male, and that wouldn't work. So this is the only thing that satisfies it. You're going to divide that by the probability of being a female. What's the probability of being a female in this case? There are 10 females out of 21 people. Remember last chapter when you divide by fractions, you do what? Multiply by the reciprocal. And look what happens. You get, that's a 10. You get 6/10. Okay? So it works. Now we're just going to go through and start doing some problems from your worksheet. Okay? So, we've got this probability table. Let's see. You might want to add them up. So, let me do that real quick. Get my calculator. You got 107 people with less than a high school education. 224 with a high school education. 438 with some college. 436. Did you happen to add all those? Let's go ahead and do that. So we have 1,205 people that have been surveyed here. We'll go ahead and add our under 20 grand. Okay, sorry, we just hit up the calculator real quick. We also added, notice there's 296 people that make less than $20,000, 505 people that make this window, and 404 people that make over $30,000. And while these wages are certainly outdated, it is still true that the majority of people that make the least amount of money are the least educated, but not all of them. Okay. All right. So what is the probability that someone has less than a high school education? Well, this is where we've already done the hard work. How many people have less than a high school education? 107. And how many people are there total in this survey? And I don't mind if you leave it like that. You can also write it as a decimal or a percent. Okay? Number 2, what is the probability that someone earns over $30,000, so is in this category, and has less than a high school education? How many people satisfy that? I think it's just 2, G. Right? And how many people are in the survey? Right next to the tissue box, kiddo. It's all right. I got to make some more copies. Multitasking during the video. Sorry. Does that make sense? Okay. Number 3. What is the probability that he earns over $30,000 and has only a high school education? That's going to be 14 out of 1,205 people, and starting to do okay at these. Number 4, what's the probability that he has a high school education or less, given that they own? So this is going to be a little trickier. If we know that they earn over 30,000, so we know they're in this category, what's the probability that they have a high school education or less? So how many is that? 16. Very good. Okay? All right. How many females? Did you happen to add these up yet? I'm going to pause the video. We'll do some addition. Okay, so we've resumed the video, and what we've done is gone through and added our rows and added our columns, and that's really the hard part. Okay? What is the probability that someone plays sports given that they are a female? How many females play sports? 39. How many people are there total? Oops, I didn't add this up. What is that? 96? 696 total. Okay. Is that good? Oh, yes, given that they are female. Correct, sorry. It should be 39 out of 334. And that makes me think we might have done the whole last one wrong. We'll go back and look after the video. We might have a 4 mix. Okay? All right, number 6. What's the probability that someone is a female given that they play sports? How many people play sports? 106. How many of them are female? 39. So 39 out of 106 people that play sports are females. Okay? Number 7. What is the probability that someone enjoys reading given that they are male? Well, how many of these people are males? 362. And how many of them, let's see, enjoy reading? 76. Okay? Number 8. What is the probability that someone is a male given that they enjoy reading? Okay, how many people enjoy reading? 161. How many of them are males? 76. So 7 and 8 kind of show you the difference. What's the probability that someone enjoys reading given that they are male? Not very high. What's the probability that someone is a male given that they enjoy reading? That's much higher. And it's just the nature of what's tricky about this. And that's what makes me think I did this whole thing wrong. I think we should look at it again. Even if I make a new video, before we move on, let's take a look at these. So, number 1, what is the probability that someone has less than a high school education? I think that's right. What is probability that someone earns over $30,000 and, okay, that I think number 2 is right. Let's see, let's look at 3. 3 might be the one we messed up. What's the probability that someone owns $30,000 given they have only a high school education? This is the one we did wrong. What should the denominator be in number 3? Very good. That's how many people only have a high school education. Does that make sense, Nathan? Okay. And let's look at the 4th one. What's the probability that someone has a high school education or less given that they earn over $30,000? I think this is the wrong denominator again. It should be 404. Now, a couple things. I think this is what I enjoy about you guys so much. You don't judge me. It's my first time teaching this. Okay? So I appreciate it. Like, I feel comfortable with my mistakes around you guys. And B, you're getting to what is so tricky about probability. It is so much about reading carefully and understanding the scenario. Okay. Number 15. The population of a high school is 51% male, 45% of the males and 49% of the females attend concerts. Make a tree diagram. So first, we can have males and females. And you write a little 0.51 here, or you can write 51%, whatever you prefer. So then you have to kind of insinuate what percentage of the population are females. If 51% are males and 49% females. Okay? Now, of the males, you've got concerts and non-concerts. You either like concerts or you don't like concerts. Okay? 45% of the males like concerts, so how many of them do not like concerts? 55. And of the females, 49% of them attend concerts. So that means 51% or 0.51 do not attend concerts. Okay, find the probability that a student is male and attend concerts. If you can get through the making of the tree diagram, this is so much easier. So for B, you just do, remember and means multiply. So you literally just do 0.51. 0.51 times 0.45. Can anybody give that to me? .2295. So about 23%. About 23%. Okay. What is the probability that a student is female and does not attend concerts? So that's going to be 0.49 times 0.51. Maybe just a little bit higher than that. So about 25% of people are females that don't attend concerts. What is the probability that a student is female and does not attend concerts? .49 times 0.49. Oh, we're on D. Sorry, D. Find the probability that a student attend concerts. Oh, find the probability that a student attends concerts. I think we got to do the probability that a male attends concerts plus the probability that a female attends concerts. No, I think they're mutually exclusive, so we don't have to subtract anything. So the probability that a female attends concerts would be 0.49 times 0.49 plus the probability that a male attends concerts will be 0.51 times 0.45. Okay? We cannot just add these two, and we cannot just average those two because we don't have the same amount of males and females. So what did you get for this little, are you doing it all at one? Okay? And that's going to be 0.4696, or about 47%. And this is what's really nice about probability and statistics. In last chapter, when you had to simplify a rational function, you had no idea if you did it right or not. You didn't know if you factored right, you didn't know if you canceled right. But now you can look at that. This answer should make total sense. About 47% of people, 45 and 49, go to concerts. Is that it? That's it. Boom. Boom. Right under 20.